This is geotrig, lesson 2 outline. I'm assuming it's going to be day 1. There'll probably be a day 2 to this. So, the first thing we'll talk about is area. What is the area of a triangle? It's the area of a triangle.
1/2 base times
Yeah, 1/2 base times height. Where did this formula come from?
origin.
The origin?
Yeah.
We're going to skip that question. I'm recording, guys. Where did the formula come from? It's really half the base times height, and base times height would give you a what? Another length times width, base times height. That's a rectangle. The next question. Area of a square or rectangle is length times width. And so if you just cut across the corner, you'll form a triangle in a rectangle. And therefore, people started to recognize that. So maybe that's where that formula came from. I'll look into that one. I don't know why it's there. Area of a circle? Pi radius squared, pi r squared. And area is the blank of any shape, not its outline.
Perimeter.
No, the perimeter is the outline.
Oh.
Area is the inside, right? It's the inside of the shape. How much space is taken up, right? So, let's do a small proof here. And we got a triangle, we're going to call it ABC. So this triangle ABC is not necessarily a right triangle. It can kind of be any kind of triangle. We know it's not right because it's not have a box in here someplace. But let's just break this into right triangles. Let's just say that I take an altitude and drop it straight down, forming two right triangles. Because we know if we have a right triangle, we know we have a height, we have a base, and we have that formula from before that we're really comfortable with using of 1/2 base times height, correct? So I broke it into triangle 1 and triangle 2. By chance, what's the area of triangle 1? Triangle 1. It's 1/2. What's the base? What's the base of this triangle right here? M. Notice that B is the big base of the big triangle, right? So B is this whole entire thing. What we did is we dropped altitude straight down, creating two separate bases, and the height is H. Number 2. What's the base? N. What's the height? H. Now, would you guys agree that if I took triangle 1 and triangle 2, I would end up with the equaling the large triangle? I don't know. Triangle L or 3, I don't know what you want to call it. Oh, it's triangle 3, yeah. I didn't look that far ahead. You get 3, right? So if I took their individual areas and added them, that should equal 1/2 base times height from the original triangle. You can ignore this one. This is triangle 3. It's kind of what we're doing. But look at this thing. This and this triangle are the same. I broke the large left triangle into 2. Adding those two together should get me back to this original 1/2 base times height because the base is B and then the height was still H. Can you guys agree with that or not? What's common? Can I factor the left-hand side? Can I factor this stuff? What's in both of these?
1/2.
And? H. So let me take the 1/2 and the H away. Wouldn't you see that you're left with M plus N? And what is N plus M? The B, isn't it? This is B. When I put the pieces back together, I get the original problem back. So that's why you get 1/2 H times B, or 1/2 base times height. Just a little bit of proof there. basically what's happening, what we did, like you can see here, is that I moved the height to the end, forming, which we would have had, a right triangle. I can take any triangle I want, and it's almost like I can create the right triangle equivalent that has the same area. That works. Because m plus n is still the base. The height still has to be the same. It doesn't matter if the height's inside the triangle or outside the triangle. As in, it's an obtuse triangle. We all know what obtuse triangles kind of look like, right? So if you had something like this, the height would be on the outside, that altitude, right? Maybe from this back corner, drop straight down to the floor here. So saying something about the obtuse triangle, find the area of that obtuse triangle. There's a couple different ways we can do this one. We can use the formula, so we'll do that real quick. The area is what? 1/2. What's the base?
8, 10, 13?
Which one is it, 10 or 13 or 8?
10.
The dotted lines, is that really part of the picture? No. So it's 10. And what's the height?
6.
So what is half of 10 times 5? Or 6, sorry, that's 5.
30.
It's 30. So whatever it is, it'd be units, it'd be feet. Feet squared. It's super easy, right?
Does it get harder?
Now, is that the only way we could have done this? No. So, what happens if I take the altitude, the height there, and I drop it straight down where it's now, forming a right triangle with the base, that happens to add an extra 3 feet. What's the area of that larger triangle? Because this is totally separate. That's the answer. The answer is 30 feet. Remember that. So would you guys say that the area of the super large one would be 1/2, 13 times 6, which is 39, right? Would that be 39? Because half of 6 is 3. 13 times 3 is 39. Okay. Okay. But that's not the triangle we want. The triangle we want is the large one minus the little one. And can we find that little area real quick? The little area, the area of the little one is 1/2, 3 times 6. Half of 6 is,
So 9.
so it's 9. What happens when I subtract those two?
You get 30. Oh, it's the same thing.
It's the same thing.
So, that way slower, that second one?
The second way is slower, but it's kind of more methodically figuring out the area versus just going straight to the formula, knowing. Once you know that the height of the triangle, whether it's inside, outside, or at the wall, the same formula can work. Because what we did with this one is we created a large right triangle which has a height and a base, and then we used the smaller triangle then to find the area. Area of the rectangle. That's an easy one.
Area of a rectangle. Oh, length. 160.
Area equals length times width, which is 16 times 10
1,000
feet squared. And 0, going to the circle, a circle with a diameter of 18.
So isn't that
So area equals pi r squared.
Oh yeah, so diameter 18.
So it's 18 divided by
18 divided by 2, which is,
9.
so it'll be squared. And 9 squared?
81.
So it equals 81.
81 pi. Inches squared. What is this thing called? Does anybody know what that shape is called?
Trapezoid.
It could be a trapezoid, right? It's only a trapezoid It would be definitely be a trapezoid if what? The top and bottom bases are not the same, but parallel. They have to be parallel. So, I think everybody can see that the perimeter, if I wanted to know the perimeter of the object, I just add up all the sides, yeah? It's 18 feet, not a big deal. But find the area of this figure. How are we going to do this?
You do 4 times 5 times 3 times 6.
Ooh, I'm not going to multiply all of those numbers together. There's a formula for this, but what if I didn't know a formula? Because probably more than likely you guys don't remember the formula. But if I said, if you guys wanted an A for today, you need to tell me the area of that. Everybody take out a piece of paper and do it. How are you going to do that without a formula? Alex.
A plus B
Shh.
over like
One
Alex.
triangle and one square.
Oh. You mean right here? Okay. What's the height?
4 feet.
What's the width of the rectangle? And the triangle base? It's 3. Break it into parts. 3 times 4? 12. 3 times 4 and divide it by 2. And the total area is? Now, is there just a coincidence that the feet, that'd be feet squared, that the area and perimeter happen to be the same? Yeah, it's just a coincidence. Notice that when I found the area, I didn't even use the fact that the triangle had a hypotenuse of 5. Care less. This is a base of a cone. A cone comes to a point. So the picture on the right is the cone standing up. You can see it. The one on the left is if you're in a helicopter above this, looking straight at it, you should just see a 2D shape that looks like a free throw area, right, of a basketball court.
Really what it looks like?
This particular shape, yes.
Oh, okay.
Okay, this is, you can make a pyramid out of any shape.
Oh, okay.
Okay, just comes to a point or a cone. So it wants to know, and it tells you that the height is 6 meters. H equals 6 meters. What is the volume? Oh, find the area.
Oh,
Sorry.
no.
We're not going to follow the directions, so actually you don't need to know the height on this one. We just want to know the height, the area, sorry. Wow.
What?
Whoa, strike that, reverse it. We're going to talk about volume tomorrow. We just want to know the area of the base, because the area of the base is part of that figure, or that object, or that formula, sorry. What's the area of that weird looking shape here? How do you think you can find it?
Length times width.
There's something we're missing. We're missing the other dimensions.
Yeah.
We don't need height. Don't care about the height right now.
So
Take
2
care-
times 3.
Just get rid of it.
2 times 2.
So do what Alex did with the other problem and break it into 2 different things. What do you see? I see a half of a circle and a rectangle. The rectangle has dimensions of 2 times 3, which is 6 meters. And the half a circle, I'll say half a circle, has a radius of 1. That's bad.
So it's got radius. Oh, that's what that was.
Pi squared divided by 2. Pi r squared, right? What's the radius? It's pi times 1 squared. That's the whole area. And I got to divide that by 2.
Oh, okay, okay.
So it's actually just, no, it's just pi over 2. So, the answer, 6 plus pi over 2 meters. Done. Remember, we're not trying to go decimals here. Avoiding them with all we have. Your homework is page 24, 1 through 15. Have a great day.
Hey, who's